So, my dear friends, let's continue. We have completed the concept of permutations. Now, in this session, let us complete the concept of combinations. And once combinations is done, we'll go ahead and start with sets. Okay, sets, relations, and functions. Then we'll do linear inequalities. Then we'll come back to probability and theoretical distribution. Then we can go for logical reason. So, if you see, my dear friends, the number of ways of selecting R things from N things, how will you do? You'll do in NCR ways. How will you calculate NCR? N multiplied backwards R times divided by R factorial. Then we have seen few important properties. NCN is 1, NC1 is also, NCN is 1, NC1 is N, NCN minus 1 is also N. We have seen NC2, we have seen NC3, we have seen NPR by NCR. Then we have seen if NCR is equals to NCN minus R, then I said if NCX is equals to NC by N will be equals to X plus 1. However, these two properties we haven't seen, but they are not that important. Next, we have seen NC0 plus NC1 plus NC2, so on till NCN is 2 power N. Next, I said you number of ways of selecting at least one thing from N things, number of ways of failing in a test, and NC1 plus NC2, so on is equals to 2 power N minus 1. Then we have seen this very important property. N should be same, R should be R and R minus 1. Then it will be N plus 1 CR. Next. After this, number of ways of selecting one or more questions will be 3 power N minus 1, each having an alternative. Then point number 7 is pending. We'll do that point number 7 today. We have completed point number 8, point number 9. And point number 9 is done. Point number 10, geometrical applications we were doing. And unfortunately, there was a current cut. Today, what we'll do, we'll complete the combinations and we'll go ahead and we'll start with the set depending upon the time. Now, if you see, this was a homework question, right? Let's go ahead and solve this homework question. If you didn't get also, it's completely fine. If you got also, it's completely fine. Now, he's telling in the next World Cup, there will be 12 teams divided into 2 groups each. See here. There are 12 teams divided into 2 groups. First group, second group. Obviously, first group contains 6 teams. Second group contains 6 teams. Okay. Team of each group will play a match against other team. From each group, top three teams will qualify. Okay. See here what is telling. In the next World Cup of cricket, there will be 12 teams divided equally into 2 groups. Divided equally into 2 groups with obviously 6 teams and 6 teams. Next, team of each group will play a match against other. Team of each group will play a match against other team in the group. Team of each group will play a match against other team in a group. So how many teams you need to select to play a match, my dear friends? You need to select 2 teams. Okay. To satisfy this condition, team of each group will play a match against other team in the group. So each group, there will be a match in between there. Okay. So first 6C2 plus 6C2. This is first match, 6C2 plus 6C2. This will be your first set of match. First round, I can say. First round. In group 1, there will be few matches. In group 2, there will be few matches. 6C2 plus 6C2. What is 6C2? 15 plus 15, which is equals to 30. See here what is telling. Team of each group will play a match against other team of the group. So first there will be matches among the group. Next, from each group, 3 top teams will qualify. Okay, from each group, 3 top teams will qualify. From group 1, 3 teams will qualify. From group 2, 3 teams will qualify. Next. For the next round, in this round, each team will play against each other. In this, each team will play against each other. In this round, each team will play against each other. So in the second round, each team will play against each other. Now, if you see in the first round, he will say, he's telling match is between the group itself. In first round, match is between the group itself. But in the second round, what is happening? These three teams together, they'll form a six teams and they'll play with each other. So in the second round, six teams will play with each other. Means we require two teams to play. 62 is 15. Okay, next. Four top teams of this round will qualify for semi-finals and play against each other. Now, semi-finals. From these six teams, four teams will go for semi-finals and these four teams will play with each other. Semi-final. Four teams will play with each other, 4C2. So what is 4C2? 4 into 3 divided by 2, which is equal to 6. Next step. Top two teams will go to final where they play best of 3. Top two teams will go to final where they play best of 3. How many minimum number of matches will be held in the next World Cup? Best of 3 is 10. Okay. Last round. Now, since, my dear friends, we are not assuming there's a concept of what do we call it? Losing here. Not concept of, there's no concept of draw here. Okay. So how many minimum number of matches will be held in studying? So these three are compulsory going to be held. Now in last round, how many minimum matches will be held? These two teams will play best of 3. So can I write here last 3 matches will be held? No, I can't say last 3 matches will be held. I'll write only last 2 matches will be held because he's telling what are the minimum number of matches to be held. Okay. Say for example, two teams are there, A and B. A has qualified in first round and second round, finished. Third round will not happen because best of 3. He's saying minimum number of matches. Be careful. It was a little tricky question in the examination. Minimum number of matches will be 2. So first what happens? In first round, group 1 will play separate, group 2 will play separate. So 6C2 and 6C2. When they come to second round, everyone will mix now. 3 teams plus 3 teams, 6 teams. 6 teams will play together. 4 teams will go to semi-final. Now these 4 teams will play together, 4C2. Okay. From these 4C2, 2 teams will play together. Now 2 teams will have 3 matches among themselves. But since he is asking minimum number of matches, I'm assuming that result comes in the first 2 matches itself. We need not go to the third match. That's the reason 2. So 30 plus 15, 30 plus 15 plus 6 plus 2. Answer is 53. A little tricky one, but make sure that you will get it. There's one more tricky question which I couldn't find yesterday. I'll find today and I'll share that tricky question. Once try to digest it, I'll give you 2 minutes time. So I hope that's why there's no issue with the sum. So let's continue then. Now geometrical applications. I already said you In geometrical application, number of diagonals in a polygon will be n into n minus 3 whole divided by 2. Okay, there is nothing special point in this. Next. Now see this next point. N points in a plane in which no points are collinear. No points are collinear means none of the points are lying on the same line. No points are collinear means none of the points are lying on the same line. Now, I am having, let us assume 4 or 5 points somewhat like this. Okay. When you are having points like this, okay, he's telling how many lines are possible. How many lines are possible? How many points you require to make a line? You require 2 points to make a line. So 1, 2, 3, 4, 5 points are there. If I require 2 points to make a line, it is NC2. How many triangles are possible? How many points are required to make a triangle? NC3. How many points are required to make a quadrilateral? NC4. Okay. So n points in a plane in which no points are collinear, number of lines are NC2, number of triangles are NC3, number of quadrilaterals are NC4. Now, n points in a plane where m points are collinear. Collinear means they are on the same line like this. Now, when they are on the same line like this, can you form a triangle? Is it possible to form a triangle? No. That's the reason I'm doing NC3 minus MC3. I'm removing the lines which are collinear. I'm removing the points which are collinear. Okay. Number of quadrilaterals. NC4 minus MC4. Why MC4? Because I am removing the points which are collinear. Okay. When they're collinear, it's not possible to form a quadrilateral or triangle. That's the reason I'm removing the points. Now, if the points are collinear, how many straight lines you can draw? Only one straight line you can draw. That's the reason you see I'm removing the collinearity and I'm adding +1. Why do you think I'm adding +1 here? Because since they're collinear, I can form one straight line. Okay. Though triangles and quadrilaterals cannot be formed, I can form one straight line. That's the reason NC2 minus MC2 plus 1. Next, a number of parallelograms. I'm telling m points are intersecting n points. How many parallelograms can be formed? Okay. First, horizontally, I need to select 2 lines. Vertically, I need to select 2 lines to form a parallelogram. So, MC2 into NC2. Horizontally, I'll select 2 lines. Vertically, I'll select 2 lines to form a parallelogram. So, MC2 into NC2, I'll go ahead and I'll get parallelogram. Okay. So, I hope the point is clear. Yes. Now, let's see few sums based upon this. This point is pending. We'll come back to this. See this question number 10. The number of diagonals in a decagon. How many diagonals are possible in a decagon? Decagon means total 10 sides will be there. N is equals to 10. So n into n minus 3 divided by 2. So 10 into 10 minus 3 whole divided by 2. So 10 into 7 by 2, 35. Next, there are 12 points in a plane, out of which 5 are collinear. When they are on same line, can you form a triangle? No. From 12 points, I require 3 points to form a triangle. But since 5 points are collinear, I'll remove that collinear points because it's not possible to form a triangle when they are collinear. So 12C3, 12 into 11 into 10 whole divided by 6, it is 220. 5C3, I hope it is 10. So 220 minus 10, 210. Next. Number of straight lines by joining 16 points, none of them are on same line. I think there is no collinearity. So how many points you require to form a straight line? 16C2. So 16 into 15 whole divided by 2, which is equals to 120. Okay. So I hope 10th one, 11th one, and 12th one, all the 3 are clear with respect to geometrical application. Next. The number of parallelograms that can be formed from a set of 4 parallel lines intersecting a set of 3 parallel lines. Okay. So from horizontal lines, I'll select 2 lines. From vertical lines, I'll select 2 lines. 4C2 into 3C2. 4C2, we have 6. 3C2, we have 3, which is equals to 80. Next. 8 points are marked on circumference of a circle. The number of chords that can be obtained. Now 8 points are there. How many straight lines can be obtained? Obviously, sir, 8C2. 8 into 7 by 2. 8 into 7 divided by 28. I hope all these points are clear. Now see here question number 12. He is telling the number of different factors of the number 75,600. How many different factors are possible for 75,600? At one point we have left, right? That's the point what I'm dealing here. How many factors are possible for 75,600? Now, how will you solve this? What you will do is that first you will do prime factorization. First, go ahead and do prime factorization. After doing prime factorization, you will go ahead and you will apply one formula, a plus 1 into b plus 1 into c plus 1, so on till z plus 1, where a, b, c, so on are powers of prime numbers. Okay, where a, b, c, so on are powers of prime numbers. See, that's just the formula we have. We don't have any derivation for this. So we'll be going to the formula. So first we'll do prime factorization. Prime factorization means you'll go ahead and you'll divide with prime numbers. Okay. So 75,600 is there. So I'll go ahead and I'll divide with 2. 37,800. Again, let's divide by 2. 18,900. Again, let's divide by 2. 9,450. Again, let's divide by 2. 4,725. No, it's not possible to divide by 2 now. I'll divide by 5. 945. 189. It's not possible to divide by 5 now and divide by 3. 21. 3 sevens, 7 ones. So if you see how many times 2 is repeated, 1, 2, 3, 4. 2 power 4. How many times 3 is repeated, 1, 2, 3. How many times 5 is repeated, 2 times. How many times 7 is repeated, 1 time. Okay. So I'll go ahead and apply the formula now. Answer will be 4 plus 1, 3 plus 1, 2 plus 1, and 1 plus 1. 5 into 4 into 3 into 2. So 5 into 4 into 3 into 2. 120 factors are possible. Okay. So total how many factors are possible? Total 120 factors are possible for the word 75,600. Okay. 120 factors. Let's see here. This is point number 7. Factors of a number expresses as a multiple of prime numbers, prime factorization. Okay. After that, number of divisors will be a plus 1 into b plus 1 into c plus 1, so on, where a, b, c, so on are powers of prime numbers. You want proper divisors. Proper divisors means you have to exclude 1 and itself. 1 and that number you have to exclude. So for positive divisors, I'll do -2. Okay, you'll get proper divisors. So can you tell me how many factors are possible for 25,600? Solve and tell me how many factors are possible for 25,600. It's a simple one. 25,600, how many factors are possible? Any answer? 25,600? I will not solve it. You only tell me the answer. So let me solve for 25,600. How much we'll get? So 25,600. 25,600. Let's divide by 2. 12,800. Let's divide by 2. 1,400. Let's divide by 2. 3,200. Let's divide by 2. 1,600. Again, let's divide by 2. 800. Let's divide by 2. 400. 200. 100. 50. 25. 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 power 10 into 5 is repeated 2 times 5 square. So 10 plus 1 into 2 plus 1. 11 into 3, which is equals to 33. So total 33 divisors are possible. 33 factors are possible for 25,600. Okay, it's a simple one, nothing much complicated. Now see these two sums, 16th and 17th. 16th and 17th. Is telling the number of ways in which 12 students can be equally divided into 3 groups. The number of ways in which 15 mangoes can be equally divided among 3 students. Okay. See here, first let's do 17th one. 15 mangoes are there. You need to equally divide to 3 students. Means first student will get 5 mangoes, second will get 5 mangoes, and third will get 5 mangoes. Okay. So what I'll do, first from 15 mangoes, I'll select 5 mangoes. 15 C5. And I'll give to that kid, and that kid will go happily. Okay. Now how many are left? 10 mangoes are left. From 10 mangoes, I'll select 5 mangoes, 10 C5. And I'll give to the second kid. Second kid will take that and will go happily. Now how many mangoes are left? 5 mangoes. 5 mangoes. I'll select 5 mangoes from that and I'll give to third kid, and that third kid will go away happily. See here what's happened. So if you see the answer came somewhat like this. The answer came as 15 C5 into 10 C5 into 5 C5. So first what I'm doing, in 15 mangoes, I'm selecting 5 mangoes, I'm giving to first kid. 10 are there. From 10 mangoes, I'm selecting 5 mangoes, I'm giving to second kid. So 5 are left. 5 is being given to third kid. Third kid will go away, he'll be happy. Now 15 C5. How can I write 15 C5? Can I write like this? 15 into 14 into 13 into 12 into 11 divided by 5 factorial. Yes. 10 C5. 10 into 9 into 8 into 7 into 6 divided by 5 factorial. 5 C5. 5 into 4 into 3 into 2 into 1 divided by 5 factorial. So numerator will be 15 factorial divided by 5 factorial whole cube. Okay. The answer is 15 factorial divided by 5 factorial whole cube. Answer is option B. That's how we'll get it, 15 C5 into 10 C5 into 5 C5. Now see this one more question. Exact in the same parallels. This one, 15th one. The number of ways in which 9 things can be divided into 3 groups containing 2, 3, and 4 things respectively. The number of ways in which 9 things can be divided into 3 groups containing 2, 3, and 4 things respectively. 9 things you need to divide into 3 groups containing 2, 3, and 4 things respectively. So first from 9 things, I'll select 2 things, 9C2. How many are left? 7 are left. I'll select 3 things, 7C3. Now how many are left? 4 are left. I'll select 4 things, 4C4. Now 9C2, 9 into 8 divided by 2, 36. 7C3, 7 into 6 into 5 divided by 6, 35. 4C4 is 1. So 36 into 35, 1260. The answer is 1260. Simple one? Yes, sir, simple one. Next. Whenever you are having questions like this 16 and 17, what you do is that just go ahead and do option verification. Okay, you need not solve the 16th and 17th question. Just go ahead and do option verification. Like 16th question is there. What we'll do, let's go ahead and select one number. N minus 1 PR plus R into N minus 1 PR minus 1 is given. Let's take any random numbers and then let's solve that sum. N minus 1 PR plus R into N minus 1 PR minus 1. This is the given question. We need not solve this. Take any random numbers. But make sure that 5 N will be greater than R. That's a basic condition, right? You cannot violate that basic condition. N must be greater than R. Let us take N is equals to 5 and let us take R is equals to 3. You can take any numbers. 5 minus 1 P3 plus 3 into 5 minus 1 P3 minus 1. So 4P3 plus 3 into 4P2. How much is 4P3? 4 plus 3 into 4P2. 4 into 3 divided by 2, which is 6. So 4 plus 18, which is equals to 22, right? Let's stick with the first option. What is first option? First option is NCR. 5C3. What is 5C3? 5 into 4 into 3 divided by 6. 10. Is it matching? No, option A is not matching. Let's see, we might have done any mistake in calculation. N minus 1 PR, 5 minus 1 P3, 4P3, N minus 1 PR plus R into N minus 1 P, R minus 1. 5 minus 1, 4, P3, 3 minus 1 is 2. So 6 into 3 is 18. Next, 4P3. 4P3 is also 4. 18 plus 4, 22. So 5C3, nothing is matching 5C3. NC3, let's check this one. N factorial divided by N minus R factorial into R factorial. That will also same. Let's see what option he gave. 5D, 16th one. 16th one is C, NPR. NPR. 5P3. 5P3, I guess we have somewhere around 60. Oh, sir, yes. We have made a mistake here. I'll tell you what mistake we have. This is P, this is not C. I'm taking C from that time. What is 4P3? 4 into 3 into 2, 24. That's now we have done combinations. No, I mixed these combinations and permutations. 4 into 3, 12 into 3. So 24 plus 36, which is equals to 60. And 5P3 is 60. Okay. Here we are having 60. Here we are having 60. The answer is 5P3, NPR. So N minus 1 PR plus R into N minus 1 PR minus 1 is 60. Be careful, this is P. I did 4C3. 4C3 is 4. 4P3 is 24. Okay. I have written 4C3 there. Don't make mistake like that. Now, question number 17. It's simple. I hope you remember. We used to do it in case of sequence and series. When it is given like this, we'll substitute n is equals to 1 and we'll check, right? So let's substitute n is equals to 1 here and let's check 2 factorial. What is 2 factorial? 1. So 2 factorial is 2, sir. Let's check in the options where you are getting 2 as answer. 2 power 1 into 1. So you are getting 2 as answer here. Yes, option B is satisfying. 2 power 1 into 1 factorial, it is 2. Now let us substitute n is equals to 2 here and let's check. N is equals to 2. 2 into 2, 4 factorial. What is 4 factorial? 24. So let's check. 2 square into 2 factorial. 4 into 2, which is equals to 8. So I'll say option B is not satisfying. Okay. See, better check for n is equals to 1 and n is equals to 2 because it's not sequence and series, it's permutations and combinations. Okay. For 1, it is satisfying, but for 2, it is not satisfying. For 2, it is 2 square into 2, 4 into 2, 8. But unfortunately, it is 24. Now let's check option C. Option B is not satisfying. Let's check option B. If you substitute n is equals to 1, you will get 2 factorial is equals to 2. Now, 1 into 3 into 5, so on till 2n minus 1 is telling. When you are taking n is equals to 1, obviously you will take first number itself. Okay. What is first number here? 1. When you have substituted n is equals to 1, you got 2 here. But you have substituted n is equals to 1, you got only 1 here. Sir, how can you get that only 1? 2 into 1 minus 1. What is 2 into 1 minus 1? 1. Is it satisfying? No, it's not satisfying again. So option C cannot be the answer. Let's check for option E. I'll substitute n is equals to 1. 2 factorial should be equals to 2. Let's check. 2 power 1 into 1 into 1. So it is 2. So at n is equals to 1, it is satisfying. Let us check whether it is satisfying for n is equals to 2 or not. To substitute n is equals to 2, you will get 4 factorial, which is equals to 24. 2 square into 1 into 3 into 2 factorial. 2 square is 4 into 3 into 2. 12 into 2, 24. Is it satisfying? Yes. So what is the answer? Option A is the answer. 2 power n into 1 into 3 into 5, so on till 2n minus 1 into n factorial. Okay. So I hope the point is clear. 17th one, any issue is there in 16th and 17th? Both of you, Geeta and Vaishnavi. For Geeta and Yogita, any issue is there in 16th and 17th, or shall we proceed further? Okay, perfect. 19th one is simple. 5 letters. How will you drop in 5 letter boxes? 5 boxes are there. 1, 2, 3, 4, 5. From 5 letters, I'll select 1 letter and I'll drop in first box. How many letters are left? 4 letters. I'll select 1 letter and drop in the second box. 3 letters are left. I'll drop in third box. 2 letters are left. I'll drop in the fourth box. 1 letter is left. I'll drop in the fifth box. 5 into 4 into 3 into 2 into 1, 120. This is 2 power n minus 1. Okay. So I hope all these questions are simple. I want you to solve this 4th, 5th, and 6th now. First solve 5th and 6th, then you can solve 4th one. That's simple. Nothing much difficulty here. See here. He's telling how many telephone connections may be allotted with 8 digits from the number 0 to 9. 0 to 9 means 10 numbers are there. 1, 2, 3, 4, 5, 6, 7, 8. Any 10 numbers I can place here, any 10 numbers, 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 any 10 numbers. See, telephone number, any 10 numbers you can place, there is no issue. So 10 power 8. The answer is 10 power. Next. See the sixth one. Don't tell sir telephone number should not start with 0. It can start with 0. There is no issue. A dealer provides you with a Maruti car and van in 2 body parts and 5 different colors. How many choices are open? Maruti car and van is there. 2 body parts are there. 5 different colors are there. And is there, right? So correcting word is into. So 2 into 2 into 5, 20. Okay. Or else for Maruti car, I'll say 2 into 5, 10. For van, I'll say 2 into 5, 10. So 10 plus 10, 20 possibilities. Okay. Next. In how many different ways 3 rings of a lock cannot combine when each ring has 0 to 9 leading to unsuccessful attempts? 3 rings are there in a lock system. First ring can have any 10 numbers, second ring can have any 10 numbers, third ring can have any 10 numbers. Obviously, it's a ring lock system. You can have 0, 0, 0 also as a passport. There is no issue. Which one, Geeta, you are selling? Fourth one? No, you can't take 10P8 or 10C8 because repetition is possible. Sixth one. No, it's not NP2, it's addition and multiplication. Okay, like connecting word is and you will be using, into connecting word is or you will be using plus. That sums. And is there no here? You can do that also, there is no issue. Each body part has 5 colors. First body part has 5 colors, second body part has 5 colors. So 5 plus 5 for Maruti car. Van, 2 body parts are there, 5 colors are there. So first body part 5 colors, second body part 5 colors. So total 20. Okay, it's an addition and multiplication side. Now 3 rings of a lock are there. You can have any 10 numbers, there is no issue. Okay, you can have 0, 0, 0 or 1, 1, 1 or 1, 1, 2. There's no issue. So 10 into 10 into 10. He's telling unsuccessful attempts. Not a successful attempt. He's telling unsuccessful attempts. How many successful attempts will be there? Only one successful attempt will be there. It is a correct passport. So 999 unsuccessful attempts will be there. Okay, if you sit and count every attempt, 999 unsuccessful attempts will come. Okay, so I hope 4, 5, 6 are clear. Simple sums, nothing much difficulty. Let me check. Still a sub which we have to solve. This rank sums are not required. Okay, they have never been asked in the examination in the past 20 years. You did not do those rank sums. This one, 87th one again. See here what is telling this 87th question. He is telling a computer has 5 terminals. Terminal 1, terminal 2, terminal 3, terminal 4, terminal 5. And each terminal is capable of 4 positions. Terminal 1 has 4 positions, terminal 2 has 4 positions, terminal 3 has 4 positions, terminal 4 has 4 positions, terminal 5 has 4 positions, including one position of rest. There is one position of rest itself. What are the total number of signals that can be made? See, terminals mean they are basically points of connection here. Each terminal has 4 points of connection. When you connect all the connections, only then your computer will start working, right? Not your computer will not work. I have to connect all the connections means I'll be using the word and here. Okay, I'll be using the word and. Okay, so 4 into 4 into 4 into 4 into 4. 4 power 5 minus 1. 1024 minus 1, 1023. Okay. So total possibilities are 1023. Not 1025, so it's 1023. Okay, so I hope the point is clear. All terminals have to connect, then only my computer starts working. So 4 into 4 into 4 into 4 into 4. But since there is a position of rest where computer won't work, I'll remove that position of rest. I'll be left with 102. Next. All these things we have done. In order to pass PE to examination, 7 subjects are there. 2 per 7 minus 1. Same question it is. 12 points are there, 3 points are collinear. I hope that also we can do. There's no issue there. See, selection 136, arrangement 245. You can see this 144th question once. In a crossword puzzle, 20 words are to be guessed, out of which 8 words have each an alternative solution. The number of possibilities are. Okay. He's telling each word has an alternative solution, he's telling. So total 20 words are there. We make some space. Total 20 words are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, so on till 20. Okay, in this 8 words have 2 alternatives, 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 2 alternatives. Balance all have only one alternative. When you complete all the answers only, then crossword puzzle will be completed, right? You have to write all the answers. You can't leave even a single answer. Every answer must be written. So connecting word will be and. So I'll say 2 power 8 into 1 into 1 into 1, so on. What is 2 power 8, my dear friends? 2 into 1. 1, 2, 3, 4, 5, 6, 7, 8. 2 power 8 is 256. Into 1 doesn't matter. Now 256. Can I say 16 square is 256? 8 into 2, 16. 16 square is 256. Okay. So that's it, my dear friends. All the points related to permutations and combinations we have completed. There are some previous year questions. What you need to do, we'll do that. There is no issue. What we'll do, let's go for sets now. Enough of permutations and combinations. Let's go for sets, functions, and relations. For this time being, if you even do the questions what I'm doing in the session, that's more than enough. Okay, even those will help you to clear the examination. Because all the concepts we are covering, we are not skipping any concept also. And 1-2 concept, what I'm skipping in that summary notes, they are very old concepts, which were asked some 10 to 20 years back. You need not expect them to come in the examination again. They are very old and they are very even outdated concepts also. Okay, because our examination syllabus was going on revised from then. So that's the reason those concepts are still lying. Okay. Now, coming to sets. What is the sets? Sets is nothing but collection of well-defined objects is called as a set. So what you are doing, you are forming a set Like say for example, I'm telling set of natural numbers. Is it well defined? Yes, it is well defined. Next, I'm telling set of odd numbers. Is it well defined? Yes, it is well defined. I'm telling set of natural numbers, set of even numbers, set of odd numbers, set of vowels, set of consonants. All these are well defined. I'm telling set of happy days. Is it a set, my dear friends? Set of happy days in a week. No, it's not a set. Because for some people, Monday, Tuesday can be happy. For some people, Friday, Saturday can be happy. Okay. The set of happy days we can't tell. So collection of well-defined objects is called as set. It must be properly defined to be called as set. Now, how will you represent them? You would always represent them in capital brackets, capital letters, enclosed in flower brackets. Like say for example, I'm telling set of first 5 prime numbers. How will you write set of first prime numbers? I'll write A capital letter is equals to bracket open 2, 3, 5, 7, 11. Set of first 5 prime numbers 2, 3, 5, 7, and 11. Okay. So first I'm writing in capital letter. I'm enclosing in flower brackets. Next, the number of elements in a set is called as cardinal number. How many elements are there here? 5 elements are there. So what is the cardinal number of A? Cardinal number of A is 5. When I am telling n of A means number of elements in a set A. It's called as cardinal number. Next is telling elements cannot repeat more than once in a set. Like I am having 0, 0, 0, 0, 99 times. B is equals to 0, 0, 0, 0, so on till 99 times. So what is n of B? Cardinal number of B will be 1 only. Because an element cannot be repeated more than once. If it is repeated more than once, you take it as only one number. Okay. Like I'm having a set like this. C is equals to 1, 1, 2, 2, 3, 3, 3, 3. Now what is the cardinal number of C? Repetition is not possible. 1, 2, 3. Cardinal number of C is 3. Number of elements in set C will be equals to 3. Next. What are the types of sets? First one is finite set. Countable set. How many, if you can count how many elements are there, it's called as finite set. All the examples what we have done earlier are finite set only. Next, infinite set. Infinite set means uncountable elements are there. I am telling set of natural numbers, set of prime numbers, set of even numbers. When you count set of numbers divisible by 5, set of numbers divisible by 6, they are uncountable. You can't count. They are infinite set. Null set. Null set means there is no element in the set. It is called as null set. I am asking you, what is an even prime number greater than 2? Is there any even prime number greater than 2? Even prime number greater than 2. Is there any even prime number greater than 2? No, there is no even prime number greater than 2. So it's a null set. Okay. I am asking numbers from 1 to 5 which are divisible by 9. Numbers from 1 to 5 which are divisible by 9. Do you know any number from 1 to 5 which are divisible by 9? No, it's a null set again. How will you represent null set? It is either represented with enclosed brackets or pi, or you will not write any element. Okay. Singleton set. Only one element is there in the set. It is called a singleton set. I'm telling set of even prime numbers. How many even prime numbers are there? Only one even prime number is there. Singleton set. Is it a singleton set or null set? I'm giving you like this. What do you think is a singleton set or null set? Be careful, that's not a null set. That's a singleton set. There is one element in the set, so it's a singleton set. Next. Equal sets. Two sets have same element, it's an equal set. Two sets have same number of elements, they are equivalent sets. Like I'm having set A is equals to 1, 2, 3. And set B is equals to 2, 3, 1. So can you see number of elements in A and number of elements in B are exactly same. So what are they? They are equal sets. Next, again I'll say n of A is equals to n of B also. So I'll say first they are equal sets. And next I'll say they are equivalent sets. Both the things can be said. Next, I'm telling A is equals to 1, 2, 3, 4. I'm telling B is equals to A, B, C, D. So is A equals to B here? No, sir. A is not equal to B. So they are not equal sets. But can I say number of elements in A are equals to number of elements in B? Yes, sir. You can say number of elements in A are equals to number of elements in B. Obviously, it is possible. So I'll say they are equivalent sets. Equivalent sets. If the elements are same, we call equal sets. If number of elements are same, we call as equivalent sets. Okay. So I hope the concept is clear. Can I say one thing? All equal sets are equivalent sets. Obviously, see here it's an equal set. And obviously it will be an equivalent set also. That's what I'm telling to say. All equivalent sets are, all equal sets are equivalent, but all equivalent sets are not equal sets. Here. All equal sets are equivalent sets, but all equivalent sets are not equal sets. That's what I wanted to tell you. Okay. Next. Subset. A set which has few elements than main set. That's called a subset. A set which has few elements of main set is called a subset. A null set is subset to all sets. A set is subset to itself. Let me give you an example. I'm having set A is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I'm having B is equals to empty. There is no element. I'm telling C is equals to 2, 3, 5, 7. I'm having D is equals to 1, 2, 3, 4, 7, 9, 10. I'm having E is equals to 2, 4, 8, 10, 12, 15. Now, a null set is subset to all sets. Yes, B is subset to A. B has less elements when compared to A. Next, C is subset to A. Yes, here 1, 2, 3, 4 are there. Here n of A is equals to 10. Next, D is subset 1, 2, 3, 4, 5, 6, 7. Yes, D is subset to A. Can I say E is subset to A, my dear friends? No, there is no relationship between E and A. You can't tell anything what relationship is there in between E and A. Because here you are having 12 and 15. There is no 12 and 15 here. To become subset, it should have few elements or all the elements. There are no few elements. 12 and 15 is not there only in the set. Next, F is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's few or all elements. So F is subset to A. Okay. When you are telling B is subset to A, then A will be superset to B. C is subset to A. C is superset to A. F is subset to A. A is superset to. You want, you can set subset and equal to, superset and equal to also. That's also fine. There's no issue. Once the subset condition is satisfied, obviously the reverse of that will be superset. Subset, superset. Universal set. A set which has all the elements in it is called as universal set. It is either denoted as mu or it is either denoted as E. All the elements it is having. Like I'm having set of natural numbers. It's a universal set. Now I'm telling A to F. What do you think is a universal set from A to F? Obviously, sir, A is a universal set because it has all elements. A set which is superset of everything is called as universal set. Okay. Don't worry, in exam, universal set will be given. You need not identify which is universal set. Straightforward questions will be asked. Now, disjoint sets. If there is no common element between two sets, it is called as disjoint set. There is no common element between two sets, we call it as disjoint sets. I am telling A is equals to odd numbers. B is equals to even numbers. Is there any common elements between A and B? Obviously, sir, there is no common element between A and B. There is no common element between A and B. Obviously, there will be disjoint sets. Okay. Next. I am telling A is subset to B and B is subset to A. Then obviously A and B will be equal sets, right? See here. I can say here A is subset to F. And I can say here F is subset to A also. Okay, because it can have few elements or all the elements. A is subset to F, F is subset to A. Right? So I'll say A and F both should obviously be equal sets. Then only A will be subset to F and F will be subset to A. Okay. Now, what do you think? If N of A is equals to K, how many subsets are possible? Let's see how many subsets are possible. I'm telling A is equals to 1, 2, 3, 4. What do you think? How many subsets are possible? First, null set. Next, every set is subset to itself. Like this is one subset, 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 subset. Next, 1, 2, 1, 3, 1, 4. Oh, I have taken 4 elements. 2 power 4, 16 are possible. Let's still check. 2, 3, 2, 4, 3, 4. Next, 1, 2, 3, 2, 3, 4, 4, 3, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Still 1. 1, 2, 4. So can you see total 16 subsets are possible? So when 4 elements are there, you got 16 subsets. So I'll say 2 bar k, number of subsets. The number of subsets will be 2 bar k. Number of proper subsets. Proper subsets means you eliminate the same set again. Okay, so it will be 2 bar k minus 1. Okay. Now, what is this union and what is this intersection? Union, intersection. The symbol of union is the symbol of intersection. Union means you are merging the sets. You call it as union. Intersection means you are taking common elements in the sets. You call it as intersection. Simple. Like say for example, I am having A is equals to 1, 2, 3, 4. B is equals to 3, 4, 5, 6. I am telling merge them. A union B. How will you merge them? Set A is 1, 2, 3, 4. Set B is 3, 4, 5, 6. So I have taken set A and I have taken set B. This is set A. This is set B. I have merged them. Now, in sense, is repetition possible? Obviously, sir, repetition is not possible. So 1, 2, 3, 4, 5, 6. So A union B is 1, 2, 3, 4, 5, 6. Now A intersection B. A intersection B means I'll take only common elements. What are common elements here? 3 and 4 are the common elements. Okay. So N of A is equals to 4. N of B is equals to 4. N of A intersection B is equals to 2. N of A union B is equals to 6. Okay. If you want, you can even develop formula for N of A union B, my dear friends. N of A union B, how did you get? I have added 4, I have added 4. 4 and 4 I have added, right? N of A plus N of B. After that, those are repeated. I have removed that repeated elements. Minus N of A intersection B. So N of A union B will be N of A plus N of B minus N of A intersection B. Okay. So union refers to merging. Intersection refers to taking common elements. Now see here. I am telling A union A. A you are merging with itself. What you will get? A only. A intersection A. Again A only you will get. A union A. A union null set. You are merging. Except you are merging with null set. Obviously the same set you will. Is there any common element between A and null set? Do you think is there any common element between A and null set? Obviously no, sir. There won't be any common element. Next, A union universal set. Let's see here. I am taking D union A. To take D union A, you are merging A and D. You will get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You will get universal set itself. Now A intersection mu. You are merging a set and you are merging universal set. You will get the same set again. Like say for example, I am telling universal set is equals to 1 to 100. A is equals to 1, 5, 7, 9, 10. What do you think A union A will be? Sorry, A union universal set. You are merging A and universal set. Obviously universal set. A intersection universal set. What is the common element between A and universal set? Obviously, sir, only 1, 5, 7, 9, 10 are common. So answer will be 8. Okay. So I hope all these points are clear with respect to sets. All the basic points we are covering. Now, complement of a set. Complement of a set means other than given set. Like say for example, I am telling universal set is 1, 2, 3, 4, 5, 6, 7, 8. Now A is given as 1, 3, 5, 7. Now what do you think A complement will be? A complement means other than set A. Okay. Other than set A means you will do universal set minus set A. From universal set you will remove A. So 1, 2, 3, 4, 5, 6, 7, 8. Now remove the A elements. 1, 3, 5, 7. What are left? 2, 4, 6, 8. Okay, A complement means other than given set is called as A complement. Can you tell me, is there any common element between A and A complement? Obviously, sir, there won't be any common element between A and A complement. What will be A union A complement then? Obviously, sir, if you merge these two sets, you'll get universal set only. Universal set. Okay. So I hope complement is clear. Complement means other than given set. A union A complement is universal set. A intersection A complement is null set. Sir, what about universal set complement? Universal set complement means universal set minus universal set, 0. What about null set complement? Universal set minus null set, which is again universal set. A complement, whole complement will be like minus of minus A. What is minus of minus A? That's A. The same way A complement, whole complement will be A. So tomorrow what we'll do is, today's session only, we will, in evening, 5th and 6th point will complete. After doing 5th and 6th point, Before starting relations, there are some sums what we are supposed to solve. Okay, related to this Venn diagrams. Those sums will solve and we'll proceed with the next one. So that's it. Balance things we'll do in the evening session. I'll let you know the time. Okay. See you in the evening.